Hello grade 11 and 12 students. In today's video, I'm going to cover Newton's first law exam questions. Just so you know, I have an entire study guide on Newton's laws. It's 150 pages long. I go through 50 worked examples like the one I'm doing in today's video. You can buy it by going to my website. I will link it in the description box below. But let's jump right into this question. Remember to subscribe for more videos just like this one. So we've got a constant force F, that's an applied force, and it is pulling a 50 kilogram block at a constant speed over a rough horizontal surface AB. Now immediately, as soon as you see the phrase constant speed, if you see constant speed, constant velocity, uniform speed, uniform velocity, you know you're dealing with a Newton's first law question, not second law. What that means is if you have this formula over here, F net equals ma, because the speed is constant, it means that acceleration is 0, and if acceleration is 0, then F net is equal to 0. So that's very, very important about a Newton's first law question. This phrase is what identifies this question as a first law question. They also give me the coefficient of kinetic friction as 0,4. Remember, coefficient of friction does not have a unit. First question, and this is supposed to be an easy question, you should get all these marks always. Draw a labeled free body diagram showing all the forces acting on the block. We are always going to make sure that our free body diagram has labels on it. So how we do it is the object is represented as a dot and the forces are drawn as arrows. So this object is resting on a surface, so therefore there's a normal force acting straight up, Fn, like that. There's also the weight of the box, Fg or W, acting straight down. The applied force is acting up and at an angle of 20 degrees relative to the surface. So your applied force is going to go up like this. F, you can call it F because they've called it F, and technically we don't have to draw this in, but you can see that this is at an angle. It's at an angle of 20 degrees. We don't draw the angle in unless they ask for us to draw it in. The box is moving to the right, so that means that friction is acting in the opposite direction of the motion. To the left, because the box is moving, we've got kinetic friction, so it's Fk, kinetic friction. We're also told that we have a coefficient of kinetic friction. So this question is 4 marks, and you should have 4 labeled arrows, just like that. Then they want us to state Newton's first law of motion, so if it wasn't already obvious from the constant speed over here, from that phrase given, that this is a first law question, they've made it even more obvious now by asking you to define Newton's first law of motion. This is the definition for Newton's first law of motion. A body or an object will remain in its state of rest or motion at a constant velocity, so you have to say both of those, rest or motion at a constant velocity, unless a non-zero resultant force acts on it, or you can say a non-zero net force. But this word here, non-zero, you have to say non-zero. The next question wants me to calculate F, force F, and just take note how F is at an angle. Because F is at an angle, we know that we should break F down into components or resolve F into components. So just to show you what that means. So F is acting at an angle like this. There's F at an angle of 20. We can break it down into 2 components. F parallel and F perpendicular, like that. Very, very important, because when we consider the net force acting on a box, we are always going to consider the net force acting parallel to the surface, so the force is acting in this direction, and then the net force in the perpendicular direction. So it's very important that if your vector is acting at an angle, to break it up into components. Now, how would you write, or how would you work out these components? Well, if I were to work out F parallel, so it's called parallel because it's parallel to the surface. This angle is 20, and F over here is the hypotenuse of the right angle triangle. So we would work out F parallel by using, now look, think about which trig ratio you would use. You're looking for the side adjacent to the 20 degrees. So we would use cos. So it would be F cos 20. If you're looking for the perpendicular component, now if you take a look at where the perpendicular component is, it is opposite the 20 degree angle, and opposite is sin or sine. So F sin 20. So this is how you would work out the components. Now, the reason why I don't have a number in the place of F is because I don't know what F is. So all I can do for now is I can write that the parallel is F cos 20. If I knew what F was, I would put a number in the place of F, and F perpendicular is F sin 20 or F sine 20. Now, still, this is not getting me anywhere. I need to work out F. So basically what the question is asking me to do is I need to find the value of F. What is the value of F? And it's 6 marks. This is a lot of marks. So what I want us to do is I want us to first relook at our free body diagram. This is why a free body diagram is so important. So this is my free body diagram. This is the one that I drew for marks. But now because I'm using it as a rough, something rough that's going to help me work out the question, I'm going to put the components on here. Remember, we only put the components on the free body diagram when you're doing a rough version of the free body diagram. We don't include the components over here, like I've done over here in blue and green, on the free body diagram that we give for marks. See how this one has no components. You will get minus marks if you do that. Now, the reason why I've done this is because we need to use the forces as given on the free body diagram to set up an equation, and we're going to use that equation to help me work out F. Now, when we set up equations for Newton's laws, we're either going to set up an equation using all the parallel forces, so the forces going like this, or all the perpendicular forces, the forces going like this. So, for example, if I want to look at the parallel forces, I'm going to highlight them for you. So this one and this one, these are parallel forces. If I add those together, so I go F net equals MA, always start off with F net equals MA. F net is the sum of all the forces. And because I'm working with the parallel forces, it's going to be the sum of all the parallel forces. So it's going to be F parallel plus FK. And that is equal to MA. But now remember, we're dealing with a Newton's first law question, which means acceleration is 0. And if acceleration is 0, it means that F net is equal to 0. So this is a 0. And we've got F parallel. Remember, F parallel we said we can write as this over here. F cos 20 plus Fk. So remember, what is the goal? The goal is we're trying to find F. Here, we're trying to find F. The problem with this equation, this would work nicely, but the problem with this equation is I don't know friction. I don't know what this is. So we've kind of hit a little bit of a road bump here. We need to kind of get over that. So how we're going to do that is as follows. How do we work out friction? There's a reason this question is 6 marks, by the way. How do we work out friction? So on the side over here, I'm going to say friction is equal to, what's the formula to work out friction? If you look at your formula sheet, you should see that friction, kinetic friction, we can work out by using the coefficient of kinetic friction multiplied by the normal force. We know what the coefficient of kinetic friction is. It was given to us in our question over here, 0,4. So I know what that is, 0,4. But another issue, another problem that we've run into is at the moment, I don't know what N is. Now, a lot of students say this to me. They say, but ma'am, isn't the normal force the same thing? So remember, normal force is the force going like that. They say, ma'am, isn't it the same thing as Fg? Now, this is very, very important, so I want you to listen to me very, very carefully. If I have an object on a flat horizontal surface like this, and there are no other forces acting in the perpendicular direction, and when I say perpendicular direction, I mean up, down. So there's no other forces acting in the perpendicular direction, then it is true that the magnitude of the normal force, Fn, is equal to the magnitude of Fg. However, in this question, this is not the case. We do have an additional force that is acting in the up, down, or the perpendicular direction. And if you've been paying attention, if you've been following what I'm saying, you will know that it is this over here. F perpendicular. Look at your free body diagram. Again, this is why it's so important to draw the free body diagram. If I take a highlighter and I highlight all of the perpendicular forces, it's not just Fn and Fg. It's not just those two that are acting in the up, down, or perpendicular direction. Yes, Fn is acting up. Yes, Fg is acting down. But we've also got this force over here. F perpendicular. The three of those forces together are acting in the up-down direction. So no, it's not the case. It's not as simple as saying, oh ma'am, I know what the normal force is. It's the same as the weight. No, not in this case. So the normal force is not equal to the weight in this question. So how do we do it? We need to take all three of these green highlighted forces, and if I add them together, so we're going to go Fn plus Fg plus F perpendicular, all of those three added together will equal 0. Now again, how do I know that those three added together will give me 0? If I consider the box in this direction, the perpendicular direction, remember Fn is going in this direction, Fg is going in this direction, and F perpendicular is going in this direction, all along, kind of like the y-axis, the perpendicular plane. The box is not moving in that plane. So the net force in this direction is 0. That's why I can add those three forces together and it should give me 0. Now, keep in mind what we're trying to do. I'm trying to look for Fn. Why am I trying to look for Fn? Because I need the normal force over here. Why do I need the normal force over here? Because I want to work out friction. And why do I want to work out friction? I need to put it in this formula to ultimately solve for F, the force F. This is a long question. So how we do it is as follows. You add the three together. Always start with what we call vector addition. So plus signs in between. Always, always, always. Then I'm going to choose up as positive. So Fn is what I'm looking for. Up is positive, but Fg is going down, which means Fg is negative. And remember, Fg, if you don't remember, is mass times gravity. So what is the mass of the box? 50. What is gravitational acceleration? 9.8. Then plus F perpendicular, which is this force over here. Remember earlier we said that F perpendicular was F sine 20, and F perpendicular is going up. See the direction that this little arrow is pointing over here? It's pointing up, which means it's going to be positive F sine 20, like that. All of that together is going to give me 0. And I know what you're thinking, ma'am, this is not helping because, again, we have F over there, which we don't know. But it's okay. We're going to simplify this. So what I'm going to do is I'm trying to work out what Fn is. It doesn't matter that there's another variable in here. This is what I'm going to do. Okay, so Fn stays on the side of the equation. I'm going to take this negative 50 times 9.8 over. So it's going to be positive 50 times 9.8. See, it was negative, becomes positive, and then this was a positive, it becomes negative F sin 20. Simplify that. Fn is equal to 490 minus F sin 20. So this over here is an expression that is equal to Fn. This is what Fn is equal to. So I'm going to take that. Remember, this is equal to the normal force. And in the place of n over here, I'm going to put all of this. I'm going to substitute. So remember, formula first, substitute. This 0,4 was given to me in the question, and now n, in the place of n, what I'm going to put here is going to be this whole thing over here. 490 minus F sin 20. 490 minus F sin 20. Okay, because this whole thing here, this entire expression over here, is the normal force. We just worked it out over here. I hope that this is making sense. Now what I'm going to do is in the place, remember all of this multiplied by this entire thing is equal to friction. So in the place of friction over here, I'm going to put all of this. I know that this is a lot, but this is a difficult question. So another thing that we have to do is remember these forces over here are the parallel forces or the horizontal forces, F parallel and friction. When I say horizontal or parallel, I'm talking about the forces acting in this direction. So I need to choose a positive direction. I choose to the right as positive. So F parallel is going to the right. That's why it's a positive, F cos 20. And then I initially started off by saying plus friction, but now when I substitute, I'm going to go like this. Okay, so F cos 20 is a positive. Now I'm going to say minus friction. Why is friction minus? Because friction is going to the left, and I chose to the right as positive. So I am minusing friction, but again, remember, friction, let's use a different color. Friction is actually all of this. This entire thing is friction. 0, 4, 490 minus, let's erase this because it's in my way, F sin 20, and that's all equal to 0. Okay, I hope you're still with me. This looks crazy, but what I hope you're recognizing, or what I hope you can see, is now I only have one variable in my equation, F and F. I only have one variable in my equation, and I'm trying to solve for F. So what you do is now it's just up to maths. From this point onwards, if you know how to do maths, you can do this. Okay, so F cos 20 carry down. We're going to multiply negative 0, 4 distributed into the bracket. So we've got negative 0, 4 multiplied by 490. That gives me negative 196. And then I'm going to say negative, again, negative 0, 4 multiplied by F sin 20. And I know that that's a bit weird for some people to understand. How can we multiply negative 0, 4 by F sin 20? But remember, sin 20 has a numerical value. So what I'm going to do on my calculator is I'm typing in negative 0, 4 and I'm multiplying it by sin 20. So I'll show you what I'm doing. I'm saying negative 0, 4 multiplied by sin 20. Let's just check if that sin 20 is positive or negative. It's actually negative. So multiplied by negative sin 20. Let's just add the little negative in there. That's what I'm doing. Press equals. And I get the following. I know that this is a big number, but we don't round off yet because we're not at the end of the question. I get positive, because a negative times a negative is a positive, positive 0,136808, at least 6 decimal places, so that's fine. F equals 0. Now, the F is a variable there. So it's kind of like saying, what I kind of did is it's kind of like saying negative 0, 4 multiplied by x2 or whatever. You multiply this number by this number, but the x, the variable, must still go there. I hope that that makes sense. And then I do like terms. So when I say like terms, this is what I mean. This and this need to be added together because they both have an F in it. So what I'm going to do is I kept that long number on my calculator, the 0,136808, that long number, I kept that in there, and I'm going to add it to cos 20. Yeah, it's adding like terms. So plus cos 20, and I get the following. I get 1,0765000678 F. Then you take the negative 196 over, because it doesn't have an F, it becomes positive 196. And then last step, which I'm going to squeeze in here, to get F by itself, we say 196 divided by this number here, 1,07, blah, 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 blah. So 196 divided by that, and I get F as equaling 182, now I can round off, 0.07 Newton. Now remember, I know it's tricky, but you're not technically supposed to round off anywhere in this part of the question, only right at the end. The next question wants me to find the normal force. Now, if you did the previous question properly, remember, we wrote an equation for the normal force. Remember this one over here? Fn is equal to 490 minus F sin 20. You already have this equation based on your previous answer. So 3.3, we wrote this equation. So all you need to do now is rewrite this equation, but now we know what F is. So in the place of F, we're going to substitute the answer for F. So I wrote my equation, I rewrote my equation, I substituted in the value for F in the place of F, and then you just calculate it. And I get, if you type that into your calculator, 427,73 Newton. Last question wants the frictional force. Now remember earlier we said that frictional force, Fk, was equal to this thing, which is called the coefficient of kinetic friction, multiplied by N. So we know what the coefficient of kinetic friction is. It's 0,4. And now we know what N is. We just worked out what N is over here. 427,73. 427,73. And yes, you can use the rounded off version of n because it's a new question. So 427,73 times 0,4, and I get 171,092, or you can round it off as 171,09 Newton. Now just please take note that these questions are asking me to calculate, I think I cut it out, but it's asking for the magnitude, which means we don't need to give direction. But if they just ask me to calculate frictional force, not the magnitude, then you would have to say 171,09 newtons to the left. You would have to give a direction. I hope that this has been helpful. I know that this was a tricky question, but again, I hope that you found this video helpful. Please look at the links in the description box below for more Newton's laws help, more exam videos, and other resources. I hope to see you in another video very soon. Bye everyone.